Hello my dear students, welcome to IMS Academy. As part of the SSC JE previous year questions, today I will be discussing the questions on geotechnical subject. So before beginning the topic, what we do at IMS Academy? Sir, we are providing a Telegram group where the schedules of the YouTube lectures will be listed in the Telegram group. In addition to this, whatever the lecture PDFs will be also provided in this group. And in addition to this, important updates related to the job notification, or if you talk about PSUs and other job notifications, and also expert sessions on important topics. In addition to this, you will get daily quizzes also. So in the description, the Telegram group link is provided for you. You can just click on the link and join the session. So let us go quickly into the topic, students. So here is the first question. The first question is, a partially saturated soil has a unit weight of 2 gram per cc and specific gravity of the soil is unit weight of solids is 2.6. If the moisture content is 20 percentile, what is the degree of saturation? So what is the given data? Here see students, if I talk here, the partially saturated, so can I take gamma is equal to 2 gram per centimeter cube given in the question. Gamma is how much, students? Gamma is equal to 2 gram per centimeter cube. Specific gravity, you can take unit weight of solids as directly specific gravity, which is 2.6. Now, my dear students, they have given water content as 20 percentile, which will be equal to 0.2. Now, see students, we have gamma is equal to gamma W into G plus E into SR upon 1 plus E. Now, the unit weight of water is 1 gram per cc. So, if I substitute here 1 gram per cc and G value as 2.6 plus E value we don't know, but we can know, my dear students, you know other equation, E into SR is equal to water content into G. So, here water content is 0.2 and G is 2.6. So, just substitute these values here. So, E is equal to, we don't know, E into SR can be written as water content into G. So, here I will be writing 0.2 into 2.6 upon 1 plus E. Now, this value will be equal to what, my dear students? The gamma value here is how much? Here it is 2 gram per cc. Agree? So, my dear students, so here if I stock here, so you can write here 3.12 divided by 1 plus E is equal to 2. Agree, my dear students? So, here E will be, on solving it, you will get E value as 0.56. Now, what he has asked in the problem? He has asked what is the degree of saturation. Now, see students, E is equal to water content to G upon SR. Now, or you can write, my dear students, degree of saturation is equal to water content to G by E. So, here water content is 0.2 into 2.6 divided by 0.56. So, here if you see the solution, if we do the calculator here, so it is how much, my dear students? 0.52 divided by 0.56. So, what is the value? It is around 92 percentile. You will get 0.928 percentile, 0.928, and this value will be equal to 92.8 percentile. I hope you are clear with this solution. If you see the option here, option D, C is the right answer. Option C, 92 percentile. Now, let me tell you what are the important things here, students. A question was asked, they have given the unit weight of soil, gamma, and using this formula, gamma is equal to gamma W into G plus ESR upon 1 plus C, we have find out the value of void ratio. And after that, what we have done, E is equal to water content to G upon SR. By using this relation, we are come up with the degree of saturation as 92.8 percentile. I hope this solution is clear for you. So, let us move quickly into the next question. Now, what is the coefficient of at rest pressure? Now, my dear students, in earth pressure, if you talk about earth pressure, there are 3 types of earth pressure. One is the at rest pressure, active pressure, and passive pressure. Now, here what do you mean by at rest pressure? When the wall remains stationary, or you can say when there is no wall movement, we say that the earth pressure is at rest pressure. So you can say, my dear students, at rest pressure there is no yielding of soil mass. What you can say? There is no yielding of soil mass here. As there is no yielding of soil mass here, students, the strain will be zero. The strain will be zero. So here how they have derived this equation is, if you talk about sigma h by E minus mu into sigma h by E, Young's modulus minus mu into sigma V by E, as there is no yielding of soil mass, you can say the strain in the x direction is zero. Now my dear students, you can say here, if I take sigma h into 1 minus mu is equal to mu into sigma V. Now what do you mean by coefficient of earth pressure? We have sigma h by sigma V is equal to mu upon 1 minus mu. I hope you are clear. Here sigma h by sigma V is nothing but what, my dear students? It is nothing but the coefficient of at rest pressure. So whenever you are solving the questions in SSC JE, if you follow this traditional method, it will be very difficult because the time is a very important factor. So directly you have to remember the formula. The coefficient of at rest pressure is mu upon 1 minus mu, or there is another formula in case of angle of repose. K0 can be written as 1 minus sin phi. So you have to just remember the formulas instead of derivation. Okay, this is as part of the SSC pattern. Now my dear students, in an isotropic soil, the permeability in x and y directions are given. What is the effective permeability? Now see students, usually when we have horizontal flow, usually in permeability, the discharge will be summation in a horizontal flow, and the permeability in vertical flow, the discharge will be same and head will be summation. Now this is a direct formula. You can say the equivalent permeability is nothing but the square root of horizontal flow multiplied by vertical flow. Here they have notated with Kx and Ky. So option D is the right answer. I hope you are clear with this. I hope you are clear with this. Okay. Now we will move on to the next topic, next question, see students. The question here is the minimum water content at which soil retains in liquid state and also process small shear strength against the flow. So here see, let me tell you small things, see student. Here what they are asking about the cascades apparatus. Now when they ask you about the cascades apparatus, my dear students, you have to have a clear understanding of this chart. You have to have a clear understanding of this chart, students. Okay, just give me a second. Let me explain you this chart. Just go through in this chart, students. Now see students, we have a chart like this. Here we call, see students, here a graph is drawn between volume, and also water content. A graph is drawn between water content and volume. Okay, here we call this point as shrinkage limit. This point is plastic limit. These are called Atterberg limits. This is liquid limit. Agree, students? And if it is more than liquid limit, we call it as liquid state. And between plastic limit and liquid limit, we call it as what, my dear students? Between plastic and liquid limit, we call it as plastic state. And between shrinkage limit and plastic limit, it is semi-solid. And below shrinkage limit, you can say it is solid. Now let me tell you, my dear students, if you have an idea on this, remember, my dear students, every year I am seeing a question from this chart in SSC JE. Now what is liquid state? Or first we will discuss about liquid limit. It is the minimum water content at which the soil has small shear resistance against the flow. When the soil is having small shear resistance, once it crosses the liquid limit, the soil behaves as a liquid. That means it doesn't have any shear resistance. And what is plastic limit is, it is the minimum water content at which a soil can be rolled into 3 mm diameter without breaking. That is nothing but plastic limit. Now my dear student, what is shrinkage limit is? It is the minimum water content at which any further loss of moisture, or it is the maximum water content up to which there will not be any change in the, even though there is a loss of water content, there will not be change in volume. Up to the shrinkage limit, the volume remains constant. But here they have given the definition of liquid limit. So here they have given clearly the definition of liquid limit. So the answer here is A. You can say the answer here is A. I hope you are following, students. So students, we will be posting this video. So if you have any queries, please like, subscribe our channel, YouTube channel, and try to comment in the comment section if you like this, so that we will deliver more and more videos. Now my dear students, when I talk about negative skin friction of piles, now let me tell you what do you mean by negative skin friction. When the surrounding soil settles more than the pile, a downward drag is observed. Due to the downward drag, the net load carrying capacity of the pile is reduced. So my dear students, due to negative skin friction, settlement will happen. Yes, it is caused in soft clays. Obviously, it decreases the pile capacity. All the above is the right answer. So negative skin friction, the net load carrying capacity will be reduced. It is observed in clays, and it will be also responsible for the relative settlement. Now see students, here is a question. Now see, the question here is, study the given statements P and Q. Based on the plastic indexity, select the most appropriate of the statements. The plasticity index is a measurement of amount of clay in the soil. When silt is added to the clay, the plasticity increases. Now my dear students, usually plasticity is the property where you measure the clay. So option P is correct. Now when silt is added to clay, let me tell you my dear students, see here what he is telling, when silt is added to clay, usually what happens, no? Usually coarser particles are having less plasticity. So when silt is added to clay is having more plasticity when compared to silt. So when silt is added to clay, what will happen to the plasticity is, plasticity will be reduced. My dear students, you should understand here, plasticity will not be increased, plasticity will be reduced. So the important point I would like to tell you, plasticity is a measure of, or like you can say the amount of, here see, plasticity is a measure of amount of clay. But when silt is added to clay, definitely plasticity will decrease, plasticity will never increase. So the second option, statement Q, is wrong. Statement P is only correct. You can say statement P is only correct. I hope this solution is clear. So my dear students, whenever you are solving SSC JEE questions, you have to be smart and you have to be fast. Now see students, we have another beautiful questions. What is the beautiful question here is, let me tell you. Study the given statements S1 and S2 regarding the permeability of the soils. The coefficient of permeability of a soil is directly proportional to the square of particle size. Permeability of partially saturated soils is greater than on the fully saturated. Now let me tell you, we have one equation. So let it be more generic, students. The equation we have is K is equal to D10 square C E cube by 1 plus E into gamma W by mu. Okay, this is the important equation. If you can remember this equation, any question can be asked, any question can be answered related to factors affecting permeability. So from this question, my dear students, permeability is directly proportional to the particle size. Rounded particles are more permeable when compared to angular particles. Even though the equation says that permeability is directly proportional to void ratio, but actually it is inversely proportional to the void ratio. More the viscosity, lesser the permeability. Now my dear students, permeability is proportional to particle size square. So this statement is correct. But let me tell you, fully saturated soils have more water flow, or you can say, what do you mean by permeability? It is the property of the soil which allows the passage of flow through it. What do you mean by permeability? It is the property of the soil which allows the passage of flow through it. So when you are saying that passage of flow, more permeability will come in fully saturated soils obviously. So you can say permeability is directly proportional to degree of saturation. More the degree of saturation, more the permeability. So definitely the second statement what they have written, permeability is more for fully partially saturated, that is absolutely wrong. So my dear students, whenever they have asked you questions related to factors affecting permeability, first point is permeability is directly proportional to the particle size whole square. When it comes to C, that is shape constant, permeability you can say rounded particles are more permeable when compared to angular particles. Permeability is inversely proportional to void ratio. Permeability increases with increase in temperature with a decrease in viscosity, and fully saturated soils are more permeable when compared to partially saturated soils. Now with this concept, not only this question, any question on the factors affecting permeability can be answered. Now let me go to the next question. The maximum water content at which there will not be any volume change. So I told you already my dear students regarding the Atterberg limits. If you see here, a graph is drawn between volume and water content. If a graph is drawn between volume and water content, you already know this graph, right? This point is called what, sir? This point is called shrinkage limit. If you see here, how the volume is there, the volume seems to be constant at every junction, or it is like a straight line. So here what I would like to tell you is, what is shrinkage limit? It is the maximum water up to which any further loss of moisture, any loss in moisture will not cause any change in volume. That point is known as shrinkage limit. So actually shrinkage limit, plastic limit, liquid limit, first of all you should remember all these are the water contents, but based on the states of the soil, the liquid state, plastic state or solid state, these will be classified. Now according to this solution, the answer is straightforward. You can write shrinkage limit. The answer is straightforward. You can write it as shrinkage limit. Now see students, let us go into the next question. Please read this question. Permeability of a soil continued to decrease with increase in dry density. Soil and water are compressible in nature. Now what he is asking, permeability of the soil continues to decrease with increase in dry density of compacted soils. And soil and water are C. What I would like to tell you here is, he is trying to say when dry density increases. Here dry density is increasing, my dear students. What is happening? Dry density is increasing. How the dry density will increase, sir? How do you say that dry density increases? If you have done the proper compaction, when you have done proper compaction and enough compaction, definitely dry density will increase. And in this case, what will happen? Void ratio will decrease, or size of the voids will also decrease. Because you are doing compaction, definitely size of the voids decrease. And remember, what do you mean by permeability, my dear students? Permeability is nothing but the property of the soil which allows the passage of flow. When you are decreasing the size of the void, definitely permeability decreases. So here you should know the correct reason is, when dry density increases, that means you are doing proper compaction. Once you have done proper compaction, size of the void decreases. So obviously permeability decreases. So the option, the statement is correct. But if you talk about soil and water are incompressible, this reason is wrong. The statement might be correct, but the reason is wrong. I hope you are clear with this solution. I hope you are clear, right, students? Now, in saturated soils, the initial consolidation is, this is a very good question, my dear students. Actually, initial consolidation, we have different stages of consolidation. Initial consolidation, primary consolidation and secondary consolidation. Initial consolidation means it is the expulsion of air from voids. Primary consolidation means it is the removal of water from the voids. What do you mean by secondary consolidation? Means it is the removal of highly viscous water. But let me tell you, here he has used saturated soils. In saturated soils, the consolidation is mainly due to the compression of solid particles. It is not due to the expulsion of air. In saturated, you can say, if they used the word saturated, consolidation is due to the expulsion of solid particles. I hope you are clear. Now see students, they have given you, as per the soil classification, if the coefficient of uniformity of a soil is greater than 6 and coefficient of curvature lies between 1 and 3, what the soil is classified as. Now let me tell you, my dear students, here, first of all, you should know what do you mean by coefficient of uniformity. First of all, you should be aware what do you mean by coefficient of uniformity. Now, what is the significance of coefficient of uniformity is, through finding coefficient of uniformity, you can know what is the particle size range, my dear students. Using coefficient of uniformity, what you can know is, you can find out the particle size range. Means from which soil size particle to which soil size. What is the minimum size of the soil particle? What is the maximum? And how do you define coefficient of uniformity? It is defined as D60 by D10. It is defined as what, sir? D60 by D10. Now, if you talk about different types of soils, we have well-graded soils. Particles of all sizes are present. Poorly graded soils, some particle sizes are missing. Uniformly graded means all the particles are of same size. So, based on coefficient of uniformity, and we have another thing is coefficient of curvature. Coefficient of curvature, what is the significance of coefficient of curvature? Anyone, my dear students? Coefficient of curvature is nothing but, here in the coefficient of curvature, what will it why we want to study about the coefficient of curvature is, here we will be studying about the shape of the curve. So coefficient of curvature will give you idea about what, sir? It gives you idea about the shape of the curve. So this is a very important point. And here, my dear students, coefficient of curvature can be written as d square 30 upon d60 into d10. So what is the purpose of coefficient of uniformity? It represents the particle size range. Coefficient of curvature represents the shape of the curve. Now let me tell you, for any soil to be well graded, it should satisfy both the conditions of Cu and Cc. Now for sand, remember, my dear students, for sand, if they ask you, Cu should be greater than 6 and Cc should be between 1 to 3. If it is having these two conditions, then we call that soil as well graded. Now luckily here, see students, they are asking the coefficient of uniformity is greater than 6 and they have given coefficient of curvature is 1 and 3. And they have given that see, as per if the coefficient of a soil is greater than 6 and coefficient of curvature, the soil is classified as, they are asking well grade. Actually, my dear students, let me tell you, when coefficient of curvature lies between 1 and 3, then it is said to be well graded. If Cu is greater than 6, then we call it as well graded sand. If Cu is greater than 4, then we call it as well graded gravel. So here it is greater than 6 and 1 and 3. Usually sand is represented by S, clay is represented by C, silt is represented by M, and you can say organic soils are represented by O. Here well graded soil is represented by W. So the answer here is well graded sand. So SW is the right answer. So you can say option 2 is the right answer. So my dear students, if you are liking this video, you have to share this video so that we will be providing you more and more videos based on the response of the students. So please keep in this mind. Now, what is the observed value of SPT test, the N value after correcting a dilatancy? Now, my dear students, let me tell you what do you mean by standard penetration test. Standard penetration test is the number of blows required for 30 centimeter penetration. So, it is just a number. So, actually there will be two corrections. One is Warburton correction and dilatancy correction. Usually, dilatancy correction will be followed by Warburton correction. See, what is Warburton correction is, sometimes if you feel it's shallow foundation, you will underestimate the number of blows. If it is a pile foundation or you can say deep foundation, you will overestimate it. So to have a uniformity, we will apply Warburton correction. And dilatancy correction is something where you will apply the number of blows in case of a water table effect is there. So there is a formula here, corrected corrected N value is given by the formula 15 plus NR minus 15 by 2. And here remember one thing students, if the recorded n value is less than 50, there is no required correction for dilatancy. But here they have given the recorded value as 21 if I am correct. So here you have to do 15 plus 21 minus 15 by 2. So this value will be equal to 18. I hope the answer here is 18. You can see option 4 is the right answer. So what is the SPT value here? The SPT is nothing but the number of blows required for 30 centimeter penetration. You can ask me, sir, why do you want? Sir, actually SPT gives you rough values of cohesion and angle of internal friction. Based on this, you can know whether the soil is dense or loose also. It gives a rough idea also. Now see students, a soil with a specific gravity of 3 and a mass specific gravity of 2. Assume the soil is perfectly dry and determine the void ratio. Now see students, he is assuming the soil to be dry, sir. And what he has given? See students. See, they have given you true specific gravity. Sir, in exam, don't try to write in an elaborate way. Okay, you have to write because time is a very important factor in SSC JEE. True specific gravity is given as G. And mass specific gravity, what is the condition of the soil? It is dry, sir. So it is given as 2. So what he is asking the void ratio. Now my dear students, you know gamma D by gamma W is the mass specific gravity. Okay, this is the mass specific gravity in which state, sir? Dry state. But let me tell you, gamma D is equal to, what is the formula, sir? Gamma D is equal to gamma W into G by 1 plus E. From this, what I can write? Gamma D by gamma W is equal to G upon 1 plus E. Now, my dear students, if I talk about gamma D by gamma W, what is the value they have given? They have given this value as 2. And what is G? 3 into 1 plus E. So, here you can, if you solve this, E will be 3 by 2, 1.5. 1.5 minus 1, it will be equal to 0.5. So, the void ratio here will be equal to how much? It will be equal to 0.5. So, here the void ratio will be equal to 0.5. So, here the perfectly dry condition they have given, sir. So, how to find out this? See students, let me tell you one important thing also here. See, whenever there is a question on properties of soil, okay, please understand this students, if you have to be aware of these formulas. If you are watching this video, definitely in GATE exam, definitely in SSC JEE exam, you will have one question from this topic, sir. So from this formula, see, gamma D can be written as gamma W into G upon 1 plus C. This is the formula for dry density, or you can write it as gamma upon 1 plus water content. And remember, we have another important formula, that is void ratio. E is equal to water content to G upon SR. Now, my dear students, mass specific gravity, if they ask you, mass specific gravity can be in saturated state. If it is in saturated state, it will be gamma sat by gamma D, gamma sat by gamma W. If it is in dry state, it will be gamma D by gamma W. And if it is in bulk state, it will be gamma by gamma W. So here you can write GM, that is mass specific gravity. And similarly, they can ask you different formulas like gamma. Gamma is nothing but the bulk unit weight, gamma W into G plus E into SR upon 1 plus E. Or you can write here, what is the saturated unit weight, anyone? So if saturated unit weight can be written as gamma sat is equal to gamma W into G plus E upon 1 plus E. So all these formulas will play a very important role in the properties of soil. At least you should be aware of these basic formulas, okay? Now, a soil sample is tested for plastic index and the plasticity index is 21. What is the condition of the soil? Now, my dear students, see, let me tell you small things here, sir. Sir, the answer is straightforward. We can do within a second. But you have to know the actual concept while solving this. Now, what do you mean by plasticity index is? Remember, my dear students, what plasticity index will give you the amount of clay in the, okay, it will give you, plasticity will give you an idea about the amount of clay in the soil. Suppose if they ask you what is plasticity index is defined as the difference between liquid limit and plastic limit. What's our plasticity index is defined as the difference between liquid limit and plastic limit. Now, my dear students, let me tell you, if the plasticity index is equal to 0, then we call it as non-plastic soil. If it is equal to 0, we can say what, sir? We can say it is non-plastic, okay? Or, my dear students, if plasticity index is less than 7, we call it as low plastic. If the plasticity index is between 7 to 17, we call it as medium plastic. And remember, my dear students, if the plasticity index is more than 17, we will call it as highly plastic. I hope you are clear with this. Okay, I hope you are clear. So here IP is what, sir? WL minus WP. And you should know IP is equal to non-zero. So here what is the answer, sir? They have given IP as 21. So it is highly plastic. So the option B will be the right answer. Now let me tell you here, see students, here there are different indices actually. Apart from the plasticity index, we have, okay, we have flow curve also. The flow curve is the nothing but the slope of flow curve is nothing but flow index. Here IF is called flow index and it is given by the formula W1 minus W2 into log N2 by N1. This is nothing but flow index. Similarly, we have toughness index is equal to plasticity index upon IF. Okay. Now, similarly, IP is called plasticity index, IF is known as flow index. We have consistency index. Consistency index is what, sir? Can anyone tell me? WL minus W upon IP. Similarly, if you talk about liquidity index is given by W minus WP upon IP. And always remember, sir, if you talk about consistency index, at liquid limit, consistency index will be 0. At plastic limit, it will be equal to 1. At shrinkage limit, it will be more than 1. And remember always, the consistency index plus liquidity index will be always equal to 1. We have another index also, that is nothing but the shrinkage index, my dear students. We have the other index also called shrinkage index. What is the formula for shrinkage index is? It is given by the formula WP minus WS. So, my dear students, I am giving you generic opportunity also. If there is a question, I am giving you the concept related to that. Actually, these are all the important indices. They can ask you any index, sir. Flow index, toughness index, or liquidity index, or consistency index, or they can ask you the shrinkage index. I hope you are clear. Now, water content of the soil can be determined by, sir, there is a shrinkage limit method, jar test, sand, but it is straight away the answer is alcohol method. The answer is alcohol method. Now, see students, if you ask me about the water content, let me tell you, we have different methods. See students, we have a method called oven drying method. Oven drying method. See, water content is determined by which method, sir? Oven drying method. And remember, my dear students, if you talk about the oven drying method, it is the most accurate method. What, sir? It is the most accurate method and a temperature of 105 to 110 degrees maintained for 24 hours. But it is most accurate method, but it will take more time. That is the reason in water content can also be determined by another method that is called calcium carbide method. What, sir? Water content can also be determined by a method called calcium carbide method. And remember here, my dear students, here you should know that calcium carbide method is the quickest method to determine the water content. What, sir? Calcium carbide is the quickest method to determine the water content. Here, what is the gas released in calcium carbide method is nothing but the acetylene gas. So here you should understand which is the most accurate method in water content, oven drying, which is the fastest method to determine water content is calcium carbide. Similarly, we have other methods like pycnometer method also, and we have the alcohol methods, radiation methods and all. I hope you are clear with this. Now see students, let us go into the next point. The water content which soil changes from liquid state to plastic state is known as. Now see students, here also you should be aware of this Atterberg limits chart. Okay, see, here we have A graph between volume and another one is what, sir? Water content. Now, my dear students, as I told you, this is what, sir? This is liquid limit. This is plastic limit. I hope you are following. And this is shrinkage limit. Here, what is the state of the soil if it crosses liquid limit? The state of the soil here is what, sir? Liquid state. The state of the soil here is liquid state. And the state of the soil between plastic limit and liquid limit is plastic state. Okay, here it is plastic state. And between shrinkage limit and plastic limit, it is semi-solid state. Here it is what, sir? Semi-solid state. And here it is solid state. Here it is what, sir? Solid state. So if I talk about the shrinkage limit and if I talk about the plastic limit and if I talk about liquid limit. So what is the problem here they have given, sir? The water is changing from liquid state to plastic state. Then what is the limit? Sir, here it is not changing from plastic state to liquid state. Okay, so here see, it is changing from, here it is changing from liquid state to plastic state. So the state of the soil is liquid limit. So the answer here is, because at liquid limit it changes from liquid state to plastic state. So the answer here is liquid limit. So option C is the right answer. Okay. Now, toughness index of the soil. Just now I have explained you. Now, my dear students, see here. What do you mean by toughness index? Here, toughness index is denoted by IT. Toughness index is nothing but it is the ratio of plasticity index to the flow index. What, sir? Toughness index, please see students. Here, what do you mean by toughness index? It is the ratio of IP by IF. IP means what, sir? Plasticity index. What is IF? Flow index. The slope of flow curve is known as flow index. And here, plasticity index to flow index. So, right answer is the first one. Liquidity index to shrinkage index, no. Liquid index, all these are wrong. So, remember, toughness index is something like you want to know the hardness of the soil. Definitely through the toughness index, you could be able to solve it. Now, a saturated soil sample has 18,000 saturated soil sample as a dry unit weight of dry unit weight. Gamma D they have given, sir. And specific gravity of 2.65. The unit weight of water is given. Determine the water content of the soil. Sir, a saturated soil sample has dry unit weight. They are not giving. Gamma D they have given. Okay. And they are asking water content. So here the dry unit weight is how much, sir? They have given in the question. If you see the question, in the question they have given dry unit weight is equal to how much, sir? Dry unit weight is equal to 18,000 Newton per meter cube. Now see students, usually in GATE exam I will tell you one logicum. Sir, see if they give you in Newton per meter cube, okay? Just make it kilonewton per meter cube, or as there is no calci there, actually 1 kilonewton, actually you can say 9.81 kilonewton per cube, or you can say gamma W is 9.81 kilonewton per meter cube, right? And see students, I'll just tell you the conversion here, this will help you. Gamma W can be written as 9.81 kilonewton per meter cube. These are the standard, or 1 ton per meter cube, or 1 gram per cc. Okay, so here if I take this as 10, I can write this value approximately as 1.8 gram per cc or ton per meter cube. Any one thing you can write. Because easy calculation. Unit weight of water is how much, sir? Unit weight of water I'll take gamma W as, even though I'll take it as 1 gram per cc. And specific gravity, they have given G is equal to 2.65. See students, you should be smart in this. If you have taken 18,000, 9,810, it will take huge calculations. So the shortcut here is, this is it seems to be very simple. You know gamma W is 9.81 kilonewton per meter cube. Here they have given 18,000 kilonewton per meter cube. I can write it as 18 kilonewton per. Now 10 kilonewton per meter cube, approximation 1 gram per cc. I have taken this as 1.8 and gamma W is 1 gram per cc and G is 2.65. So here my dear students, dry unit weight can be taken as gamma W into G upon 1 plus C. Here what is the dry unit weight, sir? You can take it as 1.8. So 1 into G is how much, students? 2.65 divided by 1 plus E. So here 1 plus E can be written as 2.65 divided by 1.8. So here if you talk about here, see students, this is also, if you take it 1.5, but if you can say, this will be equal to roughly around 1.47. Now what will be the void ratio here? Void ratio will be equal to 0.47. So actually in SSC JE students, how do we do this calculation? How I have done, I'll tell you. 1.8, 2.65. 1.8 plus 0.9 is 2.7. So I have taken 1.5 actually. So 3 into 1.8 is 54. So it is 0.54 or 0.04. So I have taken 1.47. If you do the void ratio, roughly it is 0.47. So if they have not, the answer is near to 0.41. You can write this answer. So my dear students, if you have done with the actual calculation, if you have the calculator, then it is okay. But you have to see, again I am telling you students, here you should be aware of the logic. Because usually when we take one value, it will be easy. Gamma W is how much, sir? 1 gram per centimeter cube, or is equal to 1 ton per meter cube, or you can say 9.81 kilonewton per meter cube. And I always suggest you to go with 1 ton per meter cube or 1 gram per cc for easy calculation. If you have taken 9.81, or if you have, even though they have given different values. So here if you are, sorry students, if they have given you different values here, don't use this, because in calculation you will face a lot of issues. Either go with 1 gram per cc, 1 ton per meter cube. If you are a real SSC JE aspirant students, accuracy and fast is very important. That is the reason I have told this. Now, in soil engineering, what is the volumetric definition which defines porosity? Now, let me tell you small things, Amma. Here in soil mechanics, in properties of soil, we have different properties. Actually, we are expecting a question from this, Amma. The first one we have is void ratio. So what, sir, they have asked only porosity, but I am giving you the insight of the entire concepts. Like what do you mean by void ratio? Void ratio is defined as volume of voids to the volume of solids. And remember, void ratio, the range of void ratio is always greater than 0, because never the volume of voids cannot be 0. And you see porosity. If they ask you porosity, it is defined as volume of voids to the total volume. And if you see here, my dear students, what is the relation between porosity and void ratio? Remember, the relation between porosity and void ratio is given by the formula N is equal to E upon 1 plus E. Okay, this is a very important relation also. If we talk about air content, sir, actually in voids there are two things. One, it can be air or other can be water. So how much volume of air with respect to voids, we define it as air content, and degree of saturation means how much volume of water with respect to voids, we take it as degree of saturation. So we have two things here, air content and degree of saturation. And remember, my dear students, air content plus degree of saturation is equal to 1. We have another term also called percentage of air voids, that is amount of volume of air to the total volume. So my dear students, we have 4 to 5 properties. The volume of voids to the volume of solids is void ratio. Volume of voids to the total volume is the porosity. Volume of air to the volume of voids is degree of air content. Volume of water to the volume of voids is degree of saturation. And volume of air to the total volume is percentage of air voids. And remember, percentage of air voids can be written as porosity into air content. So these relations will definitely help you. If you see this solution, your volume of voids to the total volume, option D is the correct answer. Okay, I hope you are enjoying this session. Now again and again I am telling you, my dear students, if you are really liking this session, please like the session, share the session and subscribe our YouTube channel. If you can do these things, we'll be coming with more and more videos honestly. Now, according to the Indian Standard Soil Classification, how many soil groups are there? Now, actually, I told you, no, students, actually, there is we have Indian Standard Soil Classification System. What, sir, we call Indian Standard Soil Classification System. Actually, Indian Standard Soil Classification System is derived from Unified Soil Classification System. So, it was actually described by Cascades. Now, whatever the properties, Unified Soil Classification System, Indian Standard Soil Classification System also based on that. One is the grain size distribution, plasticity characteristics and compressibility. According to the Indian Standard Soil Classification System, there are 18 groups they have classified. Usually some of the groups, let me explain you students. See here, we talk about sand. Sand is represented by C, sorry, yes. Clay is represented by C. Silt is represented by M. Usually I am telling you, my dear students. And also organic soils are represented by O. And you can say gravel is represented by G. And we have well graded means W, poorly graded means P. They can be well graded soil, silty sand, clayey gravel, silty gravel, or you can talk about the soils like low compressible silt, high compressible silt, intermediate compressible silt. Similarly, we can talk about low compressible clay and all. All these things will come under in plasticity chart. Definitely these things also will help you, students. Now, which of the following methods is used to determine the specific gravity? Remember, my dear students, when I talk about specific gravity, usually specific gravity we have taken one empty tank of pycnometer. It is determined by pycnometer actually, students. I am telling you directly. And the first one is W1 is pycnometer. Next one is weight of pycnometer plus solids, that is W2. And what is W3 here is weight of pycnometer plus solids plus water, this is W3. Weight of pycnometer plus solids plus water is W3. And we have fourth one is weight of pycnometer W4, weight of pycnometer plus full of water. And my dear students, let me tell you, here the question is simple. How do you determine pycnometer? So you can directly say pycnometer is determined by the, how do you determine specific gravity? Specific gravity is determined by pycnometer method. But here you have to see this formula. G is equal to W. How the specific gravity is determined is G is equal to W2 minus W1 minus of W3 minus W4. So this is the actual formula to determine the specific gravity. Okay. Here you should understand what is W1, weight of pycnometer. W2 is weight of pycnometer plus solids. W3 is weight of pycnometer plus solids plus water. And W4 is the weight of pycnometer plus full of water. Now, match the following is the question, see students. Standard penetration test, definitely you are going to tell how the soil is, whether it is dense or loose. So, more dense, then we can say the bearing capacity. So, standard penetration test will talk about the bearing capacity. So, you can write here A is 3. Next, hydrometer test, Proctor test, vein test. You already know. Proctor test is what, sir? Compaction. We have compaction means standard Proctor test or modified Proctor test. I am just telling C for 4. Vein test, you know already shear strength. So, D for 2. And hydrometer test is, sir, see, actually we in index properties, we have two things like we have fine grained soils and coarse grained soils. Usually relative density and sieve analysis will be useful for coarse grained soils, and for fine grained Atterberg limits or sedimentation analysis. In sedimentation analysis, you will come across the hydrometer test. So it is given as grain size analysis. So B is 1. So A3, B1, C4, D2. So A3, B1, C4, D2. So option C is the correct answer. C students here. Next, C students. Here they have given a question. The volume and weight of air, water and solids in a soil mass are given. Volume of air is 0.2, weight is 0. Weight of volume of water is 0.3, weight is 0.3 gram. Solids 0.5 and 1. So what they are asking, the soil is partially saturated with degree of saturation 60%. Now here see students, what is degree of saturation, sir? I told you just now. Volume of water by volume of voids. Here volume of water is what, sir? Here they have given as 0.3, volume of water. Volume of voids is nothing but, for your information students, it is volume of air, volume of voids is nothing but volume of air plus volume of water. So here you can write 0.3 divided by 0.2 plus 0.3, it will be equal to 0.5. So it will be 60%. So the option A, so this S1 is correct because degree of saturation. Void ratio is 40%. So what is void ratio, sir? Just now I told you. What is void ratio, my dear students? Void ratio is nothing but E is equal to volume of voids by volume of solids. Volume of voids is how much, sir? 0.5. Obviously, volume of solids will be also 0.5. So void ratio will be equal to 1. So what is the answer they have given? Void ratio is given as 40 percentile. So statement S2 is wrong. What is water content? Now see students, here if you talk water content, just I am writing here, sir. Water content is defined as weight of water by weight of solids. Weight of water is how much, sir? 0.3, and weight of solids is how much? 1. So 0.3 by 1 is 30 percentile. So statement S3 is correct. Now we talk about saturated unit weight. Sir, see here. What is saturated unit weight? Gamma sat is equal to gamma W into G plus E upon 1 plus E. Anyhow, you have known void ratio is equal to how much, sir? 1. What is the value of G they have given? The saturated unit weight is 1.5. Did they give you the which of the following statements is 1? Sir, see, actually they have to give, so G we have to find out here. G is equal to what, sir? Weight of solids by volume of solids, because gamma W will be taken as 1. Now weight of solids is how much, sir? 1, and the volume of solids is how much? 0.5. Weight of solids is 1, volume of solids is 0.5 divided by 1. So you can say G is also calculated as 2. From the table you can calculate G also. If you substitute here, gamma sat is equal to gamma sat. See students, this question will help you a lot. Even in GATE exam also it can help you. Gamma W is 2, sorry, not gamma W is 1. G is 2 plus E 1 and 1 plus E 1. So it will be equal to 1.5 gram per centimeter cube. So gamma sat is also 1.7 gram per centimeter cube. So this is also correct. So you can say 1, 3, 4 are correct. Statement 1, 3, 4, option B is correct. So statement, sir, see students, they have given all the tables. How can you solve this problem if you know what is degree of saturation? Volume of voids by, volume of water by volume of voids. What do you mean by void ratio? Volume of voids by volume of solids. What do you mean by water content? Weight of water by weight of solids. What is saturated unit weight? Gamma W into G plus E upon 1 plus E. The beautiful thing here you have to understand. Actually, true specific gravity is defined as gamma S by gamma W. And you know gamma W is 1 gram per cc. Gamma S can again be written as weight of solids by volume of solids. If they have not given G, sir, how to solve means you should know weight of solids by volume of solids. Through that we have calculated G, and G we got a value of 2. I hope you are clear. Now, a soil sample has a specific gravity of 2.5 and void ratio of 0.75. For a fully saturated, see the water content required to fully saturate the soil sample. Sir, see what they have given. Void ratio is 0.75. Sir, see, void ratio is given as 0.75 and specific gravity is given as how much, sir? 2.5. And they are telling water content required for fully saturation. Fully saturation means SR is equal to 1. Now for you, this case, E is equal to what I told you, my dear students, water content to G upon SR. So here degree of saturation, they are asking water content. So water content can be written as E into SR upon G. So void ratio is how much, sir? 0.75. Degree of saturation, anyhow it is equal to 1 upon 2.5. So what will be this value, students? It will be equal to 0.3 roughly. Okay. So this value will be equal to 0.3, or you can say 30 percentile. So here it is 30 percentile is the right answer. Now a soil sample test is a very good question. A soil sample test is carried out in a couple of set of standard ISUs. Out of 3 kgs of soil, 1200 grams of soil is on IS 600 micron sieve, 1500 grams of soil is on 500 micron sieve, and the remaining was 300 was on 425 micron sieve. What is the coefficient of uniformity? See students, let me tell you, here total is how much, sir? Total is 3 kgs of soil. Here we have standard sieves, IS 600 sieve, IS 500 sieve. Are you following, my dear students? And IS 425 sieve. What they are asking? They are asking what is the value of Cu. Cu can be written as D60 by D10. So first of all, see students, they have given you weight retained. What is the weight retained on 600? It is 1200 gram. Here it is how much, sir? 1500 gram and here it is 300 gram. If you see here, this is 40 percentile and this is 15 percentile and this is 10 percentile. And if you do the cumulative, this is 40, this is 90 percentile and this is 100 percentile. So if you do percentage, this is cumulative, students. Are you following or not? This is cumulative, this is percent 40, this is weight retained. How we get 1200 divided by 3000 into 100. Okay, cumulative is you have to add all these things. Now percentage finer if they ask you 100 minus x1. So it will be 60 percentile, it will be 10 percentile and it will be 0 percentile. So what is D60? The amount, it is first of all D60 means it is the size of the sieve where 60% is passing. What is D10? It is first of all the size of the sieve where 10% is passing. So here the answer is simple, amma, 600 micron by or 600 by 500. So this will be equal to 1.2. So the coefficient of uniformity value in this case is how much, sir? 1.2. Here you can see 1.2. Option C is the right answer. Now see students, mostly we have covered on properties of soil. Let me cover the most important things here. Properties of soil. Soil can be represented in three-phase system and two-phase system. Void ratio is volume of voids by volume of solids. And if you talk about the porosity, volume of voids by total volume. Air content is volume of air by volume of voids. Similarly, degree of saturation means volume of water by volume of voids. Air content plus degree of saturation is equal to 1. Percentage of air voids is volume of air upon total volume. It can be written as porosity into air content. Gamma is equal to gamma W into G plus ESR upon 1 plus E. E is equal to WG by SR. Gamma D is equal to gamma WG by 1 plus E. Gamma sat is equal to gamma W into G plus E upon 1 plus E. And if you talk about index properties are useful for classification and identification of the soil. It gives you rough estimation of the engineering properties of the also soil. Here we have coefficient regarding the soil, like related to the soil classification means well graded soil, poorly graded soil or uniformly graded. Based on coefficient of uniformity and coefficient of curvature we will be discussing. Coefficient of uniformity will tell you about the particle size range. It is the ratio of D60 by D10. What is D60? It is the size of the sieve where 60% is passing. D10 means is also known as effective size where 10% of the soil particles are passing. For a soil to be well graded, it should satisfy both coefficient of curvature and coefficient of uniformity. Coefficient of curvature represents the shape of the curve. It is given by the formula d square 30 upon d60 into d10. For a well graded soil, it should lie between 1 and 3. And the most important thing is Atterberg limits. What are Atterberg limits? See, these are the water contents at which soil passes from one state to the other state. We have three limits. One is the liquid limit. It is the minimum water content at which soil has small shear resistance against the flow is liquid limit. And the plastic limit means it is the minimum water content at which the soil can be rolled into 3 mm diameter without breaking is known as plastic limit. And shrinkage limit is it is the maximum water content up to which any further loss of moisture will not cause any change in volume. This is known as shrinkage limit. Actually, if you talk about the toughness index, it is the ratio of plasticity index to the flow index. Plasticity index is liquid limit minus plastic limit. And remember, for a soil, if IP is equal to 0, we take it as non-plastic. IP less than 7, low plastic. 7 to 17, medium plastic. More than 17, we call it as highly plastic. And you know, consistency index is given by the formula WL minus W by IP. Similarly, liquidity index is W minus W P upon IP, and remember liquidity index plus consistency index is always equal to 1. We also have studied about permeability. The factors affecting permeability. First of all, what do you mean by permeability is it is the properties of the soil which allows the passage of flow through it. In simple words, flow of water in the soil. What are the factors affecting permeability? Permeability is proportional to the square of the size of the particle size, where rounded particles are more permeable compared to angular particles when coming to shape effect. Permeability decreases with increase in void ratio because both are inversely related. Actually, the formula says in a different way. It is a paradox. And remember, permeability increases with increase in temperature with a decrease in viscosity. Fully saturated soils are more permeable when compared to partially saturated soils. And we have also discussed about the at-rest pressure. The coefficient of earth pressure is defined as the ratio of horizontal stress to vertical stress. When I talk about the at-rest pressure, there is no yielding of soil mass. And my dear students, as there is no yielding of soil mass, the strain will be 0. By equating that, we got coefficient of at-rest pressure is mu upon mu, 1 minus mu. It can be written as 1 minus sin phi. Active pressure means when the wall movement is away from the backfill, Ka is given by the formula 1 minus sin phi upon 1 plus sin phi. when the wall moment is towards the backfill, that is Kp, we call it as 1 plus sin phi upon 1 minus sin phi. And the product of active pressure and passive pressure coefficients is always equal to 1. So this is all about the SSC JEE questions which we have discussed. But let me tell you, my dear students, if you are really interested for these sessions, you have to like, share and subscribe our YouTube channel. And the most important thing is the view, like how you encourage with the content. If you are really understanding the content, please comment in the comment box, because based on the support you got from the students, we will be doing more and more videos. And here we at IMS Gate Academy are providing the Telegram group where everyone can join this Telegram group. In this Telegram group, the important updates related to our YouTube channel, related to the job notifications, or if you talk about the daily quizzes, or if you talk about the YouTube classroom notes, what we have discussed, we will be sharing all these classrooms in this Telegram channel. In addition to this, my dear students, important updates related to webinars, recent job notifications, like recently we have Nuclear Power Corporation India Limited also, there is a notification. So for any updates or anything, you just join our Telegram group and the link is given in the description. I hope you have enjoyed this session, and all the best for SSC JEE aspirants. Thank you and all the best.